Good day, everyone. So today we'll be discussing about this one. So the impact of jack operations relating to generator and electrical distribution system. So we have two objectives: explain the operating principles of a generator. We have three objectives rather. This first, explain the operating principles of a generator. Second, describe the electrical distribution system of a generator. And third, explain the importance of an emergency generator. Okay, so let's start. First, explain the operating principles of a generator. So as you can see, this is an example of an emergency generator. So this is the diesel engine, air cooled diesel engine, and then this diesel engine is the one that will that helps rotate the generator, or this one is the generator or the alternator. So inside this alternator we have here a simple basic diagram or a basic design of an alternator. So the alternator, the one that is rotating, is the rotor, and the one on the side, this one is not moving, this one is the stator. So as the alternator or as the rotor rotates, there is a magnet inside, an electromagnetic force is induced, and then on this side, on the stator, there are windings. This one, this yellow, green, and red, and blue, these are the windings inside the stator, and these windings will um, generate the electromagnetic force generated by the rotating rotor. They, there is a cutting of flux of the magnet, and this cutting of flux will generate electricity into these windings or windings. Okay, so that's how it works. So okay, so let's go. Okay, so the basic operating principle of an alternator or generator. So alternator is based on the interaction between the rotor's magnetic field. So here inside the rotor, this one that is rotating, that is the rotor. The rotor's magnetic field and the stator's winding. So the stator has different wires in it. So that is its windings. Okay, so as the rotor spins, this one, as the rotor spins inside, it generates a magnetic field that passes through the stator winding. So this magnetic field goes into these windings. Okay, passes through the stator winding. So this induces a current in the stator windings, which is then converted into electrical energy, like this one. This is an alternating current or electrical energy, and delivered to the external circuit or onto the consumers. So that is its basic operating principle of an alternator. And then the alternator will be rotated by another mechanism like an engine based on this picture. Okay, so that is the operating principle of the generator. Okay, next, describe the electrical distribution system of a generator. Okay, so here we have a distribution system. So we have here these are the engine 1, 2, 3, and 4. These four engines are used to run the generators. So we also have four generators. Okay, maybe let's try this one. Okay, so we have here four generators. Okay, so when the engine is started, the generator will also start. So when the generator starts, the rotor rotates, and electromagnetic force is induced, which is converted into electrical current into the windings, and this electrical current will go into the main switchboard. And then from the main switchboard, it gives electrical power to our thrusters. So this one, these are thrusters. Then it can also power up the water-cooled frequency drives. Okay, it also gives supply to the wheelhouse or the bridge, to the automation consoles, gives power to the automation consoles, automation panel. It also using also the transformer in here. So we have transformers on ships, and then it could be the 440 volts voltage is converted to 220, and then at in your rooms or in your cabin you can now charge your phones, your laptops at 220 volts. Okay, it also powers up the azimuth thrusters. So if you are having in a azimuth thrusters, so it can also power that up, and the water cooled frequency drives. And if ever, for example, if the generator fails, there is a blackout like what happened in the Baltimore Bridge. So we can also use the emergency generator. So this emergency generator will help give electricity to the emergency switchboard, and then give supply to the bridge, which is very important. Give supply to the azimuth distribution board, and to some important to steering gear, and to some important um, consumers. So what are these consumers? So let's go. Here's an example of electrical consumers on a ship. Okay, so as you can see here, we have different electrical consumers, so many electrical consumers. But if ever there will be an emergency blackout and only the emergency generator will run, automatic that the emergency generator will only supply this one, only this one. So this the line in here will be cut off, and there will be no supply on the other consumers. Okay, so what are the consumers that uses the electricity from the emergency generator? Okay, so first we have the 220 emergency light. We have the 24 volts DC emergency light. So only the emergency light are given with power. So not all the lightings on board ship are given with electrical power. Only the emergency light. So the purpose is this one is to prevent our emergency generator from running on too much load. Next, the DG lube oil priming pumps can also be used by the emergency generator power. So this diesel generator lube oil priming pump is used to lubricate our diesel generator. So to prevent it from being damaged, and then you can also start your DG lube oil, DG and diesel generator if you have this DG lube oil priming pumps. Next, the auxiliary LT freshwater pump, auxiliary high temperature freshwater pump, auxiliary seawater pump. So we can use the smaller pumps. These are the auxiliaries. So these are the auxiliary pumps. We can use the smaller pumps to prevent overloading of our emergency generator. Okay, for safety purposes also we can use the emergency fire pump. In case there is a fire, you can still use a fire pump, but it's a smaller one, which is the emergency. We can also use the emergency air compressor so that we can fill up all our air bottles, so that we can also start the generator and the main engine. We can also start one engine room air fan number 2, and then bilge pump number 2. In case of emergency, there are too much water or too much bilge in the bilges, too much bilge water, so you can pump it. Next, we have the steering gear, so that our ship can still maneuver the ship even during blackout. So as long as the emergency generator is running, so we can steer the ship using the steering gear number 2. We have the propulsion servo pump 2, the battery charger for our emergency generator, so it will be fully charged all the time. And the navigational equipments that can be used for navigating the ship. So these are the visual equipment from the bridge. So these are some of the consumers that can only be powered by the emergency generator. But if the main diesel generator will be started, any one of this diesel generator can be started, so we can automatically disconnect the emergency generator and supply all these consumers. All these consumers can be supplied by the main generator. Okay. So these are examples of the different consumers that are generators, the main generators are supplying. So these are the examples. So we have a winch and windlass. We have here, yeah, another one, winch and windlass. These are powered by our generator, main generator. The cranes on the ship. So these are not cranes from the ship. This is from the port. So cranes from the ship can be powered by the main generator. We have the deck machineries. These are powered also by this one, or oh no, this one is not electrically powered. Even the bow thrusters are powered by our generator. So as you can see how big the bow thrusters are. So this is a big motor. So usually we cannot we should use these bow thrusters slowly or in not that directly. So we just give it low power first, low speed first. You should not start the bow thruster at high speed directly. So to prevent blackout of the ship, okay? Since our ship, our generator usually can just can give can have loads, but sudden big loads are very hard to adjust for the generator. So if you use bow thrusters, especially on our deck officers, so if they use bow thrusters, so they must use it properly, not what you call what we don't have to start it on full load directly. Okay, so this bow thruster is one of the biggest consumers of load or load producers inside or in our generators. So you see as how big this motor is, bigger than a person. Okay. So those are some of the deck machineries that uses the power of our generators. Okay. But mind you, if there is a blackout and then only the emergency generator is running, so of course those deck machineries cannot be used because they are not powered by the emergency generator. Even so, let's see first. Okay, as you can see here, the bow thruster, this is connected to the main generators. But if the emergency generator is running, which is connected in here, so this one is cut. So the bow thruster can never be started during emergency generator operation. Okay, not unless if you have the main generators running. Okay, so these are the only machineries that can be used during the emergency generator operation, or if there is blackout on these three main generators. Okay. Okay, so let's go with the last one. Explain the importance of an emergency generator. So how important are our emergency generator? Okay, so the importance of an emergency generator on board the ship. So an emergency generator is a critical component of a ship's safety and operational systems. So it ensures that essential services remain functional in the event of a power failure in the main power supply. So here's a detailed explanation of its importance. So first, compliance with international regulations. So ships are required by the SOLAS, Safety of Life at Sea Convention, SOLAS Convention, to have an emergency power source. So the emergency generator must be capable of supplying power to critical systems for a specific duration, typically 18 hours or more, or 36 hours for passenger ships or more. Okay, second, the importance of an emergency generator. Second is ensure safety of life. So in the event of a main power failure, the emergency generator provides electricity to critical safety systems such as emergency lighting in accommodation areas, passageway, staircases, and exits. Firefighting equipment such as fire pumps and emergency fire pumps and emergency alarms are also powered by the emergency generator. Next, lifeboat launching systems and lifeboat lights are also powered by the emergency generator. Communication and navigation equipment such as VHF radios and radars for emergency are also powered by the emergency generator. Next, third importance of emergency generator on board ship is to maintain essential operation. So the generator support system necessary for maintaining the ship's operation during emergencies, like for example the steering gear number 2 or steering gear systems for maneuverability, the ballast systems to stabilize the ship, and cooling systems to prevent overheating of vital machineries. Fourth, it prevents environmental hazards. In case of blackout, the emergency generator power systems like oil spill prevention systems to avoid environmental contamination, like the bilge pumps to prevent water ingress and maintain ship stability. Okay, fifth, provides redundancy, so the emergency generator acts as a backup power source, ensuring continuity of operations while the main power source is being restored. So it reduces the risk of total power loss, which can lead to accidents, grounding, or collisions. Number 6, it enhances crew and passenger confidence. So the presence of an emergency generator provides assurance to the crew and passengers that critical systems will function in case of a blackout. So it is essential for the safety and morale of everyone on board. 7, it supports navigational safety. So emergency power keeps essential navigation equipment operational during power failures, including gyro compass and electronic chart systems, GPS and other positioning systems, the bridge lighting, and critical indicators. So it is also important. The importance of an emergency generator is for critical. It is for critical in extreme conditions. So during bad weather, collisions, or machinery breakdowns, the emergency generator ensures the availability of critical systems, preventing further damage or accidents. Okay, so that's it for the generator, for emergency generator, and for ship's power. Okay, so I hope you have learned something today, and I'll see you on the next one. Goodbye.